of an atom. What about mass number? Mass number is the sum of protons and neutrons in the nucleus of an element. Isotopes are atoms of an element having the same atomic number but different mass number. Take note of that. Specific examples should be drawn from elements of atomic number 1 to 20. Shape of S and P. Shape of S is spherical. Take note of that. S shape, S orbital. It is what? Spherical. The shape is what? Spherical. While the shape of P is dumbbell. Dumbbell shape. F or A, P orbital is what? Dumbbell shape. Dumbbell shape. So the shape is like this, like your 8, dumbbell. So dumbbell shape. So take note of that. Then where you have, talking about your Py now, you're saying it's moving like this. Where your P is your Py, your Px is our Px, and our Pz will move like this. Pz. So that's what we have. So next example of that isotope we are talking about is to pick fluorine as an example. Fluorine has atomic number of 17. So we have fluorine 3517, and we also have 3717 fluorine. So this is an example of what? An isotope. The objectives. Candidates should be able to distinguish between atom, molecules, and ions, which I have defined. Assess the contribution of these scientists to the development of the atomic structure, which we have talked about. Then deduce the number of protons, neutrons, and electrons from atomic and mass number of an atom. Yes, you can also deduce that if you are given, let's say, 19, then atomic number here is what? Atomic number is 9. What about mass number? Mass number is 19. Then we know that mass number is equal to atomic number plus number of neutrons. Take note of that. So if I'm to determine the number of neutrons as far as this species or atom is concerned, since the mass number is 19 and the atomic number is 9 plus n, I can calculate my n. My n will definitely be 19 minus 9, and that will be what? 10. So that means for this particular atom, there are 10 neutrons. Then apply the rules guiding the arrangement of electrons in an atom. That is what I'll be able to apply using this format. So we strike it that way. So if you have more than this, you also continue to strike. So you strike it that way. That is how you are meant to determine by using wavelength model. Then relate isotopy to mass number. Yes, I'll be able to relate isotopy to mass number. We have difference in mass number. Difference in mass number. That's isotopy. Then also perform simple calculations on relative atomic mass. Determine the number of electrons in S and P orbitals. We have done that. Relate atomic numbers of the position of an element of the periodic table. Yes. Also, by virtue of this, that has atomic number of what? 27, as in 9. So 27. So automatically, this atom will definitely be a group 7 element, because elements are placed in group based on the valence or outermost electron. And since the outermost electron here is 7, this element will definitely be what? A group 7 element. Then period. Then this element will be in period 2, simply because elements are placed in period based on the number of shells. So see how many shells do we have? K and L. Then we have 2 shells. That is why it will definitely be what? In period 2. Relate properties of groups of elements on the periodic table. So we are relating that. Then we'll be talking about atomic radius, ionic radius, ionization energy, electron affinity, electronegativity, which we are going to talk about elaborately in the subsequent slide. So the properties of groups of elements on the periodic table. We have periodic table, we have periodic law, then we have atomic / ionic radius or radii, then we have ionization energy, then we have electron affinity, we have electronegativity. The way they behave down the group and across properties across the period. First and foremost, periodic table is talking about the groups and period to which element belongs with respect to their what? Atomic number. It's the atomic number that determines the group and period to which an element belongs. So elements of the same group will definitely exhibit the same properties. Now, periodic law. Periodic law states that the properties of elements are the periodic functions of their atomic numbers. What that simply means is that it's the atomic numbers that determines what? The properties of elements. So let's talk about the properties of groups of elements on the periodic table. So in this situation, we are talking about atomic radius and ionic radius, ionization energy, electron affinity, then electronegativity. Let's talk about atomic radius. Atomic radius down the group. Atomic radius is definitely the distance between the positively charged nucleus and the electron, which is negatively charged, revolving around the orbit. Now, atomic radius, how does it respond down the group? As you move down the group, what happens to the size? As you move down the group, the number of shells increases. That means the distance between the positively charged nucleus and the what? Electron increases. And what happens in that regard is that since a number of shells is a measure of the what? Atomic number. Because as the atomic number increases, as you go down the group, atomic number increases. Therefore, the number of shells increases. So automatically, atomic radius will definitely what? Increase. It increases down the group. It increases down the group. Across the period, down the group, where you have sodium, let's say lithium, which is 2,1. Sodium, let me put it like this: lithium, sodium 281, potassium 2881, rubidium. So as you are going down, the number of shells will definitely increase. That is why it increases down the group. But across the period where you are having, let's say lithium, that's 2,1, beryllium, which is 2,2, boron 2,3, carbon 2,4. So as you are moving across the period, what happens? There is additional electron. So what happens is that as you are adding protons, you are also adding electrons simultaneously. So what happens to the size? Then there will be what? A contraction. Because this distance between the positively charged nucleus and the electron becomes what? Closer or smaller. So, and therefore, the distance is now what? Shorter. So automatically, what it means is that as we are moving across the period, the fact that proton is added, you can see that 1 plus this 2, 1 plus 2, 3, 1 plus, so there is a continuous addition of what? Electron. And as you are adding electron, you are adding proton simultaneously, since electron is a measure of what? Proton. So automatically, what happens to there will be a contraction as a result of what? Increase in nuclear charge. So what happens there is that there will be a decrease. It will decrease. decreases across the period. So that is the deduction as far as atomic radius and ionic radius is concerned. Then, ionization energy. Ionization energy is the energy required to remove an electron from an atom in a gaseous state to form an atom in gaseous ion. So what it simply means is that is the energy that is required to remove an electron. So as you are moving down the group, what happens? There is an increase in atomic number, and as the atomic number increases, the size or the distance between the positively charged nucleus and outermost electron also increases. So what happens to that? What is the effect on that? That means the valence electron can easily be what? Be knocked off, since the distance, because proton is positively charged and nucleus is negatively charged. And as the distance increases, the attraction becomes what? Lesser. And as the attraction becomes lesser, such an electron can easily be knocked off. And so therefore, ionization energy will decrease down the group. It decreases down the group. Then across the period, due to what? Increase in nuclear charge. Because of the fact that across the period, proton is added, electron is added simultaneously. As you are adding, there is an increase in the valence electron. If you look at it very well, there is an increase in the valence electron because electron is added. And as the electron is added, proton is also added simultaneously.